We're going to calculate the lattice energy here for calcium hydride. And essentially what that means is calculating delta H for the reaction calcium ion in the gas phase and then hydrogen ion in the gas phase, going to make calcium hydride solid. And we're given these various steps that we can combine to make this overall reaction, and when we do that, then we combine their delta H's. This is the idea of this Bohr-Haber cycle. And so what we're going to do is figure out how we combine these reactions. We're starting with calcium ion, and let's work with that first. So this is how we can imagine the process taking place. We start with calcium 2+, and these are gas phase, this one too. So calcium 2+ in the gas phase, add electron, calcium plus. Well, delta H for that reaction is the negative of this delta H, since it's the reverse of this reaction. So this is minus 1145 kilojoules for this 1 mole that we're carrying out the reaction for. And then the calcium plus, and just to be clear, remember these are gas phase, we add another electron to that, we can make calcium in the gas phase. That is the reverse of this reaction, so that means the negative of that reaction is delta H for the second reaction. And then we're going to take calcium in the gas phase and condense to make the solid, and we're doing this because we can see this reaction, which gives us the calcium hydride solid, requires calcium solid. So that's the reverse of this reaction here, and so therefore delta H is the negative of delta H for that reaction. Next, we're going to take H minus in the gas phase, since that's reactant, and make it H plus an electron. So that is reverse of this reaction, so this is plus 72.8 kilojoules. And then because we have 2 hydrogen ions in this original reaction, we're going to multiply this by 2, which means we need to multiply delta H by 2. And then we're going to take 2 hydrogen, and remember this is gas phase, and we're going to make H2 in the gas phase, and that's the reverse of this reaction. So minus 435.9 kilojoules. Note this reaction here is for 2 hydrogens. The last step is to take calcium solid that we formed in this step, react with hydrogen, which we formed in this step, make calcium hydride solid, our desired product for reaction, and so delta H is minus 186.2 kilojoules. So the idea is then, if we've done this correctly, we add up these reactions, we should get our desired reaction. And if that's true, we can add up these delta H's to get our desired delta H. What we want to do then is go through and cancel out what's on both sides of the equation. In other words, if we have calcium plus on both sides of the equation, we add them together, then these will cancel. Likewise, calcium in the gas phase, calcium solid, H2, 2 H's because of the 2 here, and 2 electrons here, and then because this equation multiplied by 2, so the electrons also cancel. So if we've done this correctly, what we have left is calcium 2+ in the gas phase plus 2H in the gas phase makes calcium hydride solid, And if we add these together, we get minus 2389.5 kilojoules.